Let's look at some examples for balanced chemical equations for the combustion of organic compounds that contain sulfur or nitrogen. As always, the reactants in a combustion reaction are the fuel and dioxygen. The products will be the oxides of the elements present. Carbon will form carbon dioxide, hydrogen will form water, sulfur will form sulfur trioxide, and nitrogen will form nitrogen dioxide. These are the products for complete combustion that we will use in our balanced equations. Our example asks us to write a balanced equation with integer coefficients for the complete combustion of dimethylsulfone, C2H6O2S. Again, the presence of the oxygen atoms in dimethylsulfone means that we need to be careful when balancing oxygen. The reactants should be C2H6O2S and O2. We see carbon, hydrogen, and sulfur in the material, so we know for complete combustion that the products must be carbon dioxide, water, and sulfur trioxide. As before, we'll balance oxygen last and start by assuming 1 mole of C2H6O2S. The 2 carbons would need 2 moles of CO2 on the right to balance the carbons. In order to balance the 6 hydrogens, we would need 3 moles of water. 1 sulfur on the left would result in 1 mole of SO3 on the right. There are a total of 10 oxygen atoms on the right. There are 2 in the dimethylsulfone, so we need 8 more on the left to balance oxygen. This would be 4 moles of O2. Since there are no fractions, we can use these numbers to balance the equation. Again, we do not include the ones. The next example asks us to write a balanced equation with integer coefficients for the complete combustion of trimethylamine, C3H9N. We know that the reactants will be trimethylamine and dioxygen. We need to know that the products will be carbon dioxide, water, and nitrogen dioxide. That is the chemistry part of the problem. The rest is solving the number puzzle. Starting with 1 mole of trimethylamine, we would need 3 moles of carbon dioxide to balance the carbon. To balance the 9 hydrogen atoms, we would need 9/2 moles of water. We also need 1 mole of nitrogen dioxide to balance the 1 nitrogen. To get rid of the fraction, let's multiply all of the coefficients we have so far by 2. This gives 2, 6, 9, and 2. Now to balance oxygen. On the right, there are 12 oxygens from CO2, 9 oxygens from H2O, and 4 oxygens from NO2. That is a total of 25 oxygen atoms on the right. That means that there needs to be 25/2 moles of O2. Again, to remove the fraction, we multiply by 2. And those are the coefficients, 4, 25, 12, 18, and 4, that give us our balanced equation.